Hi, today's video is about Tesla coil. What is Tesla coil? How does it work? Then after I will discuss its circuit diagram. Then after we will do a simulation of Tesla coil, and then after we will implement it practically and we'll see the results of Tesla coil. So first coming towards Tesla coil. What is Tesla coil? As we know that a Tesla coil is an electrical resonance transformer that can generate a very high AC voltage with a very high frequencies like in kilos of hertz or megahertz. Tesla coil was first invented by Nikola Tesla, and it can generate a very high voltage, low current, high frequency alternating current. I will discuss its circuit diagram like uh, what is the circuit diagram that the Tesla invented. Like it is the conventional Tesla coil. We have an AC main supply that is given to a high voltage transformer. Then we have a high voltage capacitor, a spark gap, and we have a air core high turns transformer. Here we have a few turns like 5 to 10 turns, that depends on the required voltages, and we have an air core transformer with a very high number of turns like about 1000, 1500, etc. The working principle is very easy here. Like we have 220 main supply that is converted into a high voltage AC about 20 kilovolt or 15 kilovolt, and then we have a spark gap. So when the capacitor is charged up to the voltage, and the spark gap will trigger, and here the LC circuit will oscillate, and due to transformer action a high voltage will be produced here because of high turns ratio. But here the main issue is the resonance. Like we have to tune the primary circuit LC tank and the secondary LC tank. In secondary circuit we have a top load here which have some capacitance like parasitic or stray capacitance you can call it. So by this capacitance that the torus have and this L2 inductance, so it will have some resonant frequency. So to work work this circuit correctly, you have to tune the primary LC tank and the secondary LC tank, which is a difficult task here. So moving towards another topology of Tesla coil, which is very easy, and it is also a self-oscillating circuit, that is called Slyer exciter. A Slyer exciter is a air core transformer that can step up a low DC voltages to a very high AC voltage. This create an electromagnetic field around the coil that is capable of lighting a fluorescent and neon light bulb. It is fairly similar to Tesla coil. So the beauty of this circuit is that it is self-oscillating. So I will discuss the circuit here. Here we have just a single transistor, like we have NPN or any power transistor. We have a DC voltage here like 9 volt. You can give any voltage like 50 volt, 30 volt, that depends on your requirement, and we have such circuit combination. The straight capacitance, like it is clearly shown in this figure. Like we have top load here that will have some capacitance with respect to earth or ground. So the beauty of this circuit is that you are not required to tune this LC tank by as we can see clearly see that the secondary coil is given a feedback from the base of the transistor, so it will be self-oscillating circuit. uh, in simulation I will discuss about the working of the circuit, like how the circuit works, and we will see the output of this circuit. So I have done the simulation in LTSpice. I will open the circuit here. Here we have the slide exciter based Tesla coil. I have given 30 volt DC here, and I have simulated the circuit same as I discussed here. Okay, so here I have connected the capacitor here that is about 10 picofarad. As we know that the top load have a very small capacitance, So you can give any value like 1 picofarad or 10 picofarad, that depends on you. So I have given it a 10 picofarad in the simulation. That is the capacitance of the top load, or you can call it a stray or parasitic capacitance. So by explaining the working principle of this circuit, first I will explain the circuit and then we will simulate and we'll see the output results. So first, as we know that there are two paths for the current to flow. One path is here and the other path is here. So uh, current current cannot pass through this path because the transistor is switched off, and this path is not connected to the emitter, means the collector and emitter are not connected electrically, so current will not pass through the primary coil to the ground. So first current will flow here through the base of the transistor. So due to this, as we know that when the base potential is greater than the emitter potential, then the transistor will turn on. As we can clearly see that the base of the transistor is connected to 30 volt through this current limiting resistor, and the emitter is connected to ground. So we have enough voltages here, like it is as we know that if VBE is greater than 0.7 volt, then this collector will be connected to the emitter. So here in this case the base potential is greater than emitter, so the transistor will turns on and the current will flow through this primary coil through this path and will flow to the ground to a negative potential. So as current rises here through this path, it will generate some magnetic flux, and as we know that these two are linked together with I have also defined the coupling factor. So when the current flow through the primary coil, it will generate some magnetic field, and that magnetic field will be linked to the secondary coil. So according to Faraday, it will produce or generate some voltages here. Also, you can clearly see that the dot convention of the transformer, like if the primary coil is in clockwise direction, then the secondary coil must be in anti-clockwise direction. The dot is here, but for the secondary coil the dot is in the upside. Okay, so when the current flow here, magnetic field will be generated. That magnetic field will be linked to the secondary coil, and let's suppose that this point is positive, this point is positive, then according to dot rule or dot convention of the coupled inductors, this point will be positive, which means this point will be negative. So when the current flow here, the magnetic field will induces and it will generate some voltages here, which have this point will be positive and this point will be negative, which means the negative potential will come here to the base of the transistor, and which uh, it will increase in such a way that this diode turns on. How this diode turns on? In normal condition, this diode is reverse biased, but when potential generate, when the voltage induces here, like this thing, this point is positive and this point is negative, then the negative voltage will build up here, and such that when this point is more negative than this point, as we know that in diode, if P point or the positive point is more potential than N side, then the diode will turn on. So as we know that this potential is negative, this potential negative will builds in such a way that this point will be more negative than this point, and this diode will be turned on, which means the base of the transistor will be pulled down to ground. So when this base of the transistor is at ground, this means this transistor will again turn off, which again means that there will be no current flow here. So if there is no current, there will be no magnetic field induces here, and if there is no magnetic field here, which means this will be not linked to this coil, and no voltages will be generated here. So there will be no negative voltage here, and this point will be again connected to this VCC or V applied voltage. So again the current will flow here, and this base will be at high potential, this then emitter, and current will flow here, which will again generate magnetic field. That magnetic field will induce voltages here, and this point will be at high potential than this point, which means this point will be at negative potential. Again this negative potential will build up here in such a way that this diode will turn on, and when this diode turns on, which means the base of the transistor will be connected to ground, and again this transistor will be turned off. So again and again the transistor will be on and off, and the frequency of that oscillation depends on the frequency of this circuit. Like as we know that this is an LC tank which have a frequency of 1 over under root LC multiplied 2 pi, 1 divided by 2 pi under root LC. So what, like if it have a frequency of if it have a resonant frequency of, let's suppose 1 megahertz, then the switching here will be at 1 megahertz. So the working principle of this circuit is very easy, and you can understand it very easily. So I will run the simulation and we will see whether this circuit oscillates or not. Like here, this is the voltage that build up from 0 to 30 volt, that is the input voltage, and the output is here, and we can see clearly it can be clearly seen that the circuit is oscillating, having a frequency of, like it have a frequency of about it's 0.3 megahertz or 333 kilohertz, 100, 200, 300, about 300 kilohertz. So this circuit is oscillating, and like if the input voltage is about 30 volt, the output is about plus minus about 19 kilovolt or 18 kilovolt. So if the AC voltage is if the input voltage is 30 volt, then the output voltage is about plus minus 30 volt. So this is very simple circuit, and that is self-oscillating circuit, and it can generate about plus minus or an AC voltage of 19 kilovolt when the input is 30 kilovolt. It also depends on the turns ratio of the transformer. Like if the primary, I give it if primary, if I use 5 to 3 or 5 turns, and at secondary if I use about 1500 turns, then we can literally get about 20 to 30 kilovolt high frequency AC voltages. So now coming to the practical implementation, and you will see that in that the circuit is working very correctly, and you will be shown that how the fluorescent light or the tube light lights up when it brings near to the Tesla coil, because as the Tesla coils generate very high voltages, which means it will generate a high magnetic field with high frequency, and when a fluorescent tube or a bulb is brought near to the Tesla coil, it will glow, because in the bulb or the tube light we have some gases, and we have also phosphorus inside that. So due to that magnetic field, electric field and magnetic field produced by Tesla coil, that will excite the gas inside the tube light and it will glow. So coming to a practical implementation.